Hello, good day. In Germany, we need to ventilate our rooms often, continuously, by opening the doors and opening the windows. The problem is that we sometimes forget because we are too busy with our stuff, or we might be out of town. Therefore, me and my teammates want to create a system that allows to automate this process. Today we want to show you our Internet of Things projects called Smart Home Ventilation System with ESP32. My teammates consist of three. Me, my name is Aga, and the other two, Jatin and Enrico. Let us show you the simulation of our project. For this project, we use three different ESPs, ESPs32. One is for the outdoor area, one is for the communication center, and one is for the indoor area. If we see outdoor area, we have two different sensors. One is anemometer to measuring the speed of the wind outside, and also the BME. This BME measures the temperature of the surroundings, the humidity, and also the air quality. Also, we have two actuators here. One, as a replacement of the humidifier, we have LED for the sake of the simulation. And also we have a ventilator that is being controlled through relay. And if we see here in the indoor area, we have three actuators. We have three servos. One is being connected to the door, and two are being connected to the window. And there is another BME sensors to check the indoor of the temperature, the humidity, and the air quality of the room. And at the middle here, you see the communication center. It is responsible to get the data from the outdoor and the indoor ESPs. Not just that, through this communication center, the user could send a commando so that it could control the actuators within the outer area and also the indoor area. Therefore, the communication protocol we use here, we use MQTT within the scope of the ESP32s, and we use the HTTP server, HTTP protocol to communicate with the ESP32 and the clients. So now let's see the web page system. Within the web page here, we could see the census value. And also we could control the windows, the doors, the fans, if there is a fan within the room, and also an absorber or dehumidifier within the room. Here we have a modes and a status panel. Within the mode, we could choose between manual or auto. If we choose manual, we could open the window manually or open the door manually. If we set auto, then it will kind of wait until the value meets the criteria. The interesting things about this web page is that we have two modes of auto. One is eco and one is the best. The differences between eco and the best is that within the echo, it will see if there is a wind outside. If there is a wind outside, then the fan will not be turned on. But if there is no wind at all, it's not windy, then the fan will be turned on. If the best is being chosen, if the room is too humid, then the fan will be turned on. If the window is open, of course. Both of this type of the auto, best and echo allows the window open only if the humidity inside is too high. One additional feature is there is this schedule within this auto mode. Within this schedule, we could change whether all day should the mode be best, or we could add some time period. Within this period of time, we could choose what kind of mode is better for the system. We could send it, and if it is out of the schedule, then the user could override the mode manually. So the user needs to open and control the window and the doors manually. Now, let's see the component of our simulation. First of all, there is this communication center. We have this communication center that connected to ESPs, and there is a screen here that shows us the indoor and outdoor ESPs, whether it has been connected to the internet. We have here the router, a mobileless router for the sake of the simulation. We have here Raspberry Pi as a web server. This web server allows the data being transmitted from here to here, and then from here we could see the web page here on the screen. And also from this we could control the simulation right here through the web server. The web server will kind of send it to the communication center, and the communication center will pass along to the ESPs around here. The communication between the ESP communication center here to the indoor and outdoor using MQTT protocol, and to the user here using the HTTP protocol. Now, let's see the plan here. We see there is this outdoor and indoor ESPs. This is the indoor ESPs. The servo right here has been integrated with the door, and two servos for the windows are integrated and connected to the ESP indoor right here. Additionally, behind there is a PME sensors that detects the temperature, the humidity, and air quality inside of the room. For the sake of this, it's a box. And also, we have these ESPs outside. This is the outdoor ESPs on the top of the box. It has been connected to the PME sensor right here, the PME sensor, the anemometer sensor, and also other actuators like this LED as a dehumidifier, and also relay here for the fan inside the window. That is all that is being connected to this ESP32 outdoor. Additionally, we have this. This is a controller, a manual controller to create an artificial humidifier. If we click this, we will kind of create a sprout of water so that inside of the room will kind of get humid. Now, let's simulate this project. If we click this button, it will kind of open the window since the mode is manual. The window is open and the fan will be turned on. And the fan is off and the window is closed. If we click the absorber, the LED for over there will gonna be turned on. These cables are being connected to the relay because in this laboratorium we could connect this and adjust the voltage for the ventilator. So now let's see if we set it to the auto. As you see here, the status is quite normal. That is why the window and the doors are closed. Now, let's see what happens if we turn on the humidifier. You see, the fan is being open, the window is open, and the door over there is also open. The reasons why the window is open is because the mode is auto echo. Now, I have turned off this artificial humidifier. Now let's see what happened if the anemometer here detects a wind. Let's turn on the artificial humidifier and let's see what happens if there is a wind. As you see, the fan is off because it detects a wind over there. But if it's off, the fan will soon be turned on. You see? The fan is turned on. Now let's see if we change this to the best. You see now everything has been closed, the window and the door. and then we turn on the artificial humidifier, see what happened. And if I turn on the fan, simulating there is a wind outside, the fan is still on. The reason is because of this mode, best. That is all to the simulation. This is a trial of the fan. What if we use a 12-volt battery right here, the little battery here? Let's see. The fan is working, but it might be not as fast as it's being connected through the cable to the main source there. Compared to that, this one is much slower, but it works if we have the right cable to it, which is not ideal for this simulation. If there's a socket for this battery, that would be great. That's all, thank you. We hope with the simulation of our prototype could inspire others to create an innovative solution to our daily problems. At the end, we want to say thank you to Hochschule Fulda and Professor Christoph König to allow us to do these projects. And thank you for those who has been watching our videos. Bye bye.